We all love the maverick moments, the afterburners kicking in, pulling 9 Gs, going supersonic. It's the glamorous side of military aviation that gets all the movie screens. But here's the gritty reality. A $100 million fighter jet is nothing more than a very expensive titanium paperweight if it can't get off the ground. And the absolute truth of air superiority is that it's not won in the sky, it's won on the flight line. Welcome to 2026. Military aircraft have evolved into hyper-complex flying data centers. And because the aircraft have changed, the way we fix them had to change too. The days of a mechanic just grabbing a wrench and a grease-stained manual are dead. Today, we are facing unprecedented operational tempos and an ever-present squeeze on manpower. To keep 5th and 6th generation fighters like the F-35 Lightning and the B-21 Raider mission-ready, global air forces have had to fundamentally rewrite the rulebook on maintenance, repair, and overhaul. In this video, we are stepping inside the hangar to show you the sci-fi reality of aircraft maintenance today. From artificial intelligence that orders its own parts to digital twins and frontline robotics, this is how the world's most advanced combat aircraft are kept in the fight. Step onto any major military flight line today, and the first thing you'll notice is what's missing: the paper. For decades, military maintenance was heavily reactive and bogged down by administration. If a jet landed with a problem, a technician would literally have to flip through thousands of pages of technical orders, often printed in massive binders, just to troubleshoot the issue. It was slow, it was tedious, and it meant aircraft sat on the tarmac for days. But by 2026, the hangar has gone entirely mobile first. When a technician walks up to an aircraft today, they aren't carrying a binder. They are carrying a ruggedized, military-grade tablet synced securely to a localized cloud. We call this the fully integrated digital ecosystem. Think about a modern jet for a second. An F-35 doesn't just fly, it constantly monitors its own health. It generates terabytes of data during a single combat sortie. In the past, downloading and analyzing that data took hours. Today, it happens the exact second the aircraft's wheels touch the tarmac. Through secure 5G and tactical data links, the jet essentially texts the maintenance crew before the pilot even shuts down the engine. The digital logbook pops up on the crew chief's tablet, highlighting exactly which fault codes triggered during the flight. But it doesn't stop there. This ecosystem instantly cross-references those fault codes with the global supply chain. Before the mechanic even turns a screwdriver, the system has already checked if the replacement part is in the base warehouse, ordered it if it isn't, and pulled up the exact 3D digital schematic for the repair. This total elimination of paper means what used to take 4 hours of administrative guesswork now takes 4 seconds. It ensures zero gaps in regulatory compliance, keeps the global inventory perfectly synced, and most importantly, gets the wrench in the mechanic's hand faster than ever before in aviation history.
React is a group of engineers that were put together to solve sustainment challenges. When an aircraft needs a part, we're here to provide whatever information we need to. So that can be providing a tech data package to be able to produce the part traditionally. It can be 3D printing the part from scratch, or a whole gambit of different data sets that our customers might need to be able to make smart decisions to be able to fly that aircraft.
Well, if you look at it, our React Lab is really an engine for innovation. We're constantly looking for ways to both reverse engineer and then manufacture those parts that we may have problems with, both within our own walls and then be able to create tech data packages to then push out to other locations to be able to print them across the globe, whether that's at a forward operating location or one of our stateside bases. We really form the foundation of combat readiness across the Air Force.
Rapid sustainment challenges is really what we grew out of. We have an aging fleet that's breaking in ways we didn't expect them to break because we're flying aircraft longer than they were originally designed for. The Air Force figured out it's a lot cheaper to take an old aircraft and modify it and give it new capabilities than it is to buy a whole new weapon system from the ground up. We're no longer tied to one company producing the part and hoping that we're their priority at the time. Castings, which was a huge challenge for us to be able to produce, now we can do it all internally. And we can pour up to 120 pounds of aluminum in our foundry right now at Tinker Air Force Base. So because we reverse engineer and create our own tech data package, it opens up all the possibilities to how we want to manufacture or acquire that part in the future.
They try to push the envelope on advanced manufacturing and how to apply that to problem sets across the Air Force in terms of diminishing manufacturing sources of supply, and as well as to help our program depot maintenance lines keep the throughput going so that we keep that aircraft availability to the warfighter where it's needed.
Now let's talk about the brain behind the hangar. In the old days, we practiced reactive maintenance. Something breaks, you fix it. Then we moved to scheduled maintenance. You replace a part every 200 flight hours just to be safe, even if it's still working perfectly. But in 2026, we've entered the era of CBM+, Condition-Based Maintenance Plus, powered by Agentic AI. Modern engines, like the Pratt & Whitney F135, are packed with thousands of microscopic sensors. They aren't just monitoring temperature and oil pressure, they're listening for ghosts in the machine. Agentic AI doesn't just sit there waiting for a red light to flash. It's an active participant. It analyzes high-frequency vibrations and thermal signatures that a human ear or a standard computer would never catch. Imagine a fuel pump. To a mechanic, it looks fine. To the pilot, it feels fine. But the AI notices a microscopic fluctuation in the power draw, a signature it recognizes from a failure that happened on a different jet 3 months ago in a completely different theater. The AI doesn't just flag it, it acts. It runs a probability model and realizes this pump has a 92% chance of failing in the next 15 flight hours. Before that failure can happen mid-air, the AI agent automatically places a work order, reserves the hangar space, and alerts the crew. By the time the jet lands, the mechanic isn't wondering what to fix. They're standing there with the part in hand. This isn't just efficiency, it's a revolution. We are no longer fixing planes because they're broken. We're fixing them because the AI saw the future. And that transition has slashed aircraft on ground by nearly 40% across the fleet. If you walk into a high-tech maintenance hub today, you might see an engineer staring at a screen that looks like a high-end video game. But they aren't playing. They're looking at a digital twin. For every tail number in the sky, every single individual F-35, B-21, or C-17, there is a living, breathing virtual replica stored in a secure server. This isn't just a 3D model. It is a mathematical mirror of that specific physical aircraft. Think about it this way. 2 jets might come off the assembly line on the same day, but tail number A spends its life flying low-altitude, high-humidity missions over the Pacific, while tail number B spends its time in the dry, dusty heat of the Middle East. Their digital twins reflect those differences. Every hour of turbulence, every hard landing, every degree of heat, and every salt spray encounter is uploaded from the physical jet to its virtual twin. Engineers can then run time-accelerated simulations on the twin. They can virtually fly that specific airframe through another 500 hours of combat to see exactly where the stress fractures will appear before they manifest on the real-world metal. This allows us to perform surgical maintenance. Instead of stripping the entire skin off a fuselage to look for cracks, the digital twin tells the mechanic, "Look at the 3rd rivet on the left wing spar. That's where the fatigue is." In 2026, we aren't just maintaining machines, we're managing their digital ghosts. It's the ultimate bridge between the physical and the virtual, ensuring that when a pilot pushes that airframe to the limit, they know exactly how much strength is left in the bones of the plane. In a perfect world, every jet would be fixed in a pristine million-square-foot hangar in the United States. But in 2026, the front line is often a remote, dusty airstrip thousands of miles from the nearest supply hub. This is where expeditionary manufacturing comes in. In the past, if a $50 bracket snapped on a C-17 in a remote part of the Pacific, that aircraft was grounded for weeks while a replacement part made its way through a global logistics chain. Not anymore. Today, maintenance teams deploy with mobile manufacturing units, essentially high-tech shipping containers packed with industrial-grade 3D metal printers. If a part isn't in stock, the technician simply pulls the certified CAD file from the cloud and prints a flight-ready titanium or aluminum component right there on the spot. We've shifted from shipping the part to shipping the file. But it's not just about making parts, it's about inspecting them. Look up at the fuselage of a massive transport plane today, and you might not see a mechanic on a ladder. You'll see an autonomous inspection drone. These drones are equipped with high-resolution thermographic cameras and AI-driven LiDAR. In the time it takes a human to climb a scaffold, a drone has already flown a pre-programmed pattern around the entire aircraft. It detects microfractures, lightning strike damage, or even a single loose rivet that's invisible to the naked eye. By the time the drone lands, it has uploaded a 3D damage map to the crew's tablets. This human-machine teaming doesn't replace the mechanic, it gives them X-ray vision.
My name is Staff Sergeant Kyle Richmond, and I'm the Virtual Reality Training Program Manager for the 521st Air Mobility Operations Wing Regional Training Center at Ramstein Air Base, Germany. What makes our program unique is that we couple the virtual reality training with experience. Our instructors actually insert themselves into the virtual reality training environment with the trainees. This enables instructors to share knowledge they've gained through experience to help trainees understand not only how a step is performed, but why it's important. This has been shown to increase retention when performing the task on an actual aircraft in a real-world scenario. All right, so right now, this is indicating fire. It's showing everything I talked about, right? I think the program is really good as far as, in my past experience, getting an aircraft to train on has been very difficult, and a lot of times it's either broken for one thing or the other, so sometimes it's limited as to what we can actually do on the aircraft. The great thing about virtual reality is that it's readily available. If I'm on night shift and I've got downtime, I can come up here and train on a task and keep my proficiency up. In addition to that, coupling with an instructor has really been shown to enhance training. For example, when working with the CRS, we had one senior airman in the training module who did the VR and tested him against a staff sergeant who didn't. The senior airman outperformed the staff sergeant by 10 minutes in the task, having gone through the virtual reality before. The great thing about virtual reality training is that we have the ability to connect remotely throughout our 4 geographically separated units, and we can connect with them from the comfort of our own base. Coming out of the pandemic such as COVID, this enables us to keep the mission going and training aircraft maintenance professionals and keeping them proficient in tasks and sharing that knowledge that only we would have that the modules won't necessarily be able to tell them because it's a step-by-step TO.
If you don't have innovation, you have no progression. That's very important to have in every unit, regardless of what job you're doing.
We ran into the issue where either C5s or C17s would need to be de-iced with glycol. And that process is in and of itself dangerous on multiple levels. So there's all these factors, and then we're putting people who've never done this before into these de-ice vehicles, which are giant trucks with a boom on them that just sprays this fluid onto the aircraft, right? So people get up in the air and then they freak out and they get really scared and nervous. But if I can teach you the muscle memory for what all these switches do, and you go out there and you have an emergency on your first time, you're gonna have a setup to be prepared and you're gonna succeed. I can put somebody in the chair and say, okay, touch the airplane with the nozzle. Now we're gonna back up 5 feet. And then I can say, okay, look at this and focus on it for a minute. This is what it looks like to be 5 feet from the airplane. We ran everybody in the squadron at least 1 or 2 hours through it, and then they went out and they did their portion. And what that does is it cues them up and it gets them asking the questions and, well, what if this happens? Or how does this happen? And so we can have that conversation.
We generally work on the C-17s and the C-5s. So with C5 guys coming here, they know their aircraft. C17 guys, they know their aircraft. But 17 guys that come here, they don't know C5s. So in order for us to do training without any kind of harm, any kind of damage to the aircraft, the C5 VR is beautiful. It does refuel, defuel, it does APU fire, any kind of like thing that you actually need to have more of an extent knowledge of the aircraft, it has it here. So with the auxiliary power unit, there's a lot of numbers and stuff you got to be aware of, a lot of different kind of like steps that you have to be aware of, like the sequence of the start. It's a lot easier to see that in VR and be able to talk to the students and be like, hey, this is the step, this is what happens, this is the next step, this is what happens. And they can visually see that. You have no foul, no harm. So like if you decide that you want to go into VR, mess around with it, see what buttons do, you're not going to mess anything up. If you end up getting lost, you can just restart from the steps. Right now we're working on a way to, instead of having controllers, you actually just have like gloves on your hands. They can actually like touch switches and they can turn knobs instead of like just highlighting it with the controller and pulling the trigger. So it's a lot more, it's more immersive.
With all this high-tech machinery, you might think the role of the human mechanic is shrinking. Actually, it's the opposite. But the way we train and empower these men and women has been completely reimagined for 2026. We are currently facing the largest technical skills gap in history. To close it, the military has turned the training manual into an immersive experience. New recruits no longer spend months staring at static diagrams in a classroom. They put on virtual reality, VR headsets, and step into a digital hangar. They can explode a virtual jet engine, walk inside it, and practice complex maneuvers 1,000 times before they ever touch a real multi-million-dollar piece of hardware. They can fail, they can break things, and they can learn from those mistakes in a zero-risk environment. But the real magic happens on the flight line with augmented reality. Imagine a junior mechanic tasked with a repair they've never done before. They put on an AR headset, and suddenly the physical engine in front of them is overlaid with digital instructions. Glowing arrows point to the exact bolt that needs turning. A digital ghost of the wrench shows them the correct angle of approach, and the torque specs appear floating in midair. If they hit a snag, they can initiate a "see what I see" call. A master sergeant sitting 5,000 miles away at a sustainment center can look through the junior mechanic's eyes in real time, drawing digital annotations on the actual hardware to guide their hands. In 2026, every mechanic on the front line has the collective knowledge of the entire Air Force available at the tap of a headset. We've turned every technician into a master technician.
My name is Joseph Fisher. I'm a senior airman at Phase. I'm with the 5MXS and I love my job. Right now I'm working in Phase specifically. That's the big inspection we do, just to cover all the little things that we'd miss during a normal daily inspection.
After every 450 flying hours, an aircraft comes into our dock to get pan washed, and then we do depaneling. We vacuum in areas where they're dirty, kind of like a car wash, and then we lube and do inspections, fixes.
On the flight line, it's go, go, go. Like every single day you're hopping on the truck with a little toolbox, you're headed out to a jet to do a daily inspection or to do some little maintenance to get the thing back in the air. In Phase, we take our time, we go through every single point. Every bolt on the aircraft is looked at.
So the importance is, number one, overall safety. We're making sure the aircraft is airworthy. The second piece is giving those hours back for the flying hour program so we can continue to fly.
As we look across the flight lines of 2026, it's clear that the grease monkey era has evolved into something far more sophisticated. We are witnessing the birth of the digital crew chief. The wrench is still there and the oil is still black, but the brain behind the repair is now powered by a global network of AI, digital twins, and augmented reality. We've moved from a world where we fixed things because they broke to a world where we ensure they never break in the first place. Because in the high-stakes world of military aviation, good enough doesn't cut it. When a pilot pushes that throttle forward into the dark, they aren't just trusting the titanium and the software, they are trusting the thousands of hours of predictive data and the precision of the mechanics who prepared that jet for the fight. The technology we've looked at today, from 3D printing spare parts in a desert to drones that spot microscopic cracks, isn't just about saving money, it's about readiness. It's about ensuring that when the call comes, the fleet is ready to answer. But what do you think? Is the rise of agentic AI and digital twins the ultimate shield for our pilots, or are we becoming too reliant on the ghosts in the machine? Drop a comment below. I want to hear your thoughts on which 2026 tech you think is the biggest game changer. If you found this deep dive into the world of military MRO fascinating, hit that like button and subscribe to the channel. We've got more deep dives into the future of defense technology coming your way very soon. Thanks for watching The Line with us. See you in the next one.
Soldiers, sailors, and airmen, I have full confidence in your courage, devotion to duty, and skill in battle. We will accept nothing less than full victory.